All right, so you will find two equations for this problem in your textbook that will help you out. And so to do this, well, for part A, we are interested in finding the sample size for both problems. But in part A, we have a previous estimate of 0.28, and this is referring to uh, the proportion. So for prior estimates on a problem like this, we will need to use the following equation. Let's see. N equals, oh, let's put it over here. So if we have a prior estimate, we would use the equation N equals P hat 1 minus P hat. And Z alpha over 2 over E. E is the margin of error. And then if we have, actually, we'll just do this problem before we get into B. So we have a previous estimate of 0.28. So estimate meaning P hat, that would be P hat is equal to 0.28. And we are given the margin of error that's given to you in the problem. That is the part that says within a certain amount, meaning the plus or minus of your kind of like a confidence interval. So our margin of error is that 0.03 that's given right here. Within 0.03. Okay, so that's your margin of error, E. And then we also, the last part that we need to figure out is Z alpha over 2. And actually, save room. Let's move this over here. Oh. So Z alpha over 2. Now you can use StatCrunch for this. I don't want to get into that, but you could using the 90% confidence. For 90% confidence, we can find the critical value, or Z alpha over 2. And we would figure out that this is equal to 1.645 for 90%. If you had 95%, it would be 1.96. You may remember these. And anyways, you have similar problems to this in this section where you have to find a critical value based on a certain level of confidence. In this case, 90% is 1.645. Okay, and now we can start plugging things in. So this is equal to 0.28 P hat, 1 minus 0.28. And Z alpha over 2 is 1.645. And over E. E is 0.03. Then we want to square that. Okay, so that's the calculation. I don't actually have a calculator in front of me, but you'll notice that the solution is right here, 607. And you will also notice that your value, I just know this, that the value is going to be in between, for n, that you'll find from this calculation. It's not going to be exactly 607, but it'll be less than 607, but greater than 606. You always round up to the next whole number. Never round down. That's the tip. Warning. Never round, and I'm referring to your final answer, round n down. So, okay, so this is going to be approximately 607 after you round up. Okay, hopefully that makes sense. Then part B, we'll be using that other equation because we know that that there's does not have a prior estimate. So if he doesn't have a prior estimate, you use the equation N equals 0.25. So 0.25 replaces this p, 1 minus p. And then you just have z alpha over 2 over margin of error. Okay, so we just need to use this piece of information and this piece of information down here. And so that's equal to 0.25 times z 1.645, z alpha over 2, over 0.03. Let me square that. And that's approximately equal to, apparently, 752. You'll always notice that when you use this 0.25 equation, that will maximize your n. And that is because the p hat times 1 minus p hat, if there's no prior estimate, they're assuming that p hat is equal to 0.5. You're going to take 0.5 times 1 minus 0.5, and that's always equal to 0.25. So that's where the 0.25 comes from. They're assuming p hat is 0.5. And that always maximizes your n. Okay, so again, never round n down. I know that this value is going to be between 751 and 752. You always round up to 752. Even if you have like 751.1, you'll always round that. You'll round it up to 752. You may be tempted to round down because you think of the rounding rule of below 0.5. Or 0.5 or less than 0.5 you round down. That does not apply here. Always round up. Any decimal amount, just round it to the next whole number. Always round up. Okay, so let me know if you have any concerns, and I'll be more than happy to assist.